Okay, on page 9, about in the middle of the page, we're going to talk about perpendicularity. Has anybody ever heard the word perpendicular before? Awesome. Fantastic. So when we're talking about things that are perpendicular, we're saying that they form right angles to each other. When two lines are perpendicular, they very specifically form 4 right angles. We usually only see the box drawn in one of the corners, but all of the other angles here would also be right angles. So 4 right angles. Because they are all right angles, all 4 angles are congruent. Because they're all 90 degrees. So when we are told that things are perpendicular, I automatically know now that we have 4 right angles in the image. And then at the top of the next page, we are going to practice with this. So once you're done with that on page 9, we're going to flip over to page 10. We're going to do a couple practice problems. Okay. So in the picture at the top of page 10, they've got this little, what's called a tangram. It's these little puzzle pieces that have been put together. The important thing to note here, though, is that we are getting some right angles. It tells me that line AD, this line right here, and line EC, this line right here, are perpendicular. So they are making 4 right angles. And they want us to find X and Y. Well, I see X in 2 different places. I see X here, and I see X here. And those 2 angles are side by side. They share this side right here. And together they are making this 90-degree angle. So angle EBF together with angle DBF those would have to add up to 90 degrees up here, this corner. Angle EBF, according to the picture, is 7x plus 10. And angle DBF, according to the picture, is 8x plus 5. And that equals 90. So then we combine our like terms together of 7x and 8x. That gives me 15x. And I combine my other like terms of a positive 10 and a positive 5. What would that combine to give me? 15. So 15x plus 15 equals 90. Then I minus 15 from both sides. What is 90 minus 15? 75. And then we divide both sides by 15. What is 75 divided by 15? 5. So x is 5. And down here at the bottom, this is the only place where we have y. It's right here, angle ABC. And angle ABC is a right angle. So ABC equals 90 degrees. Angle ABC is 3y plus 15. So 3y plus 15 equals 90. We solve this for y by minusing 15 from both sides like we did in our other problem. So I get 3y equals 75. And then I divide both sides by 3. What is 75 divided by 3? 25. Nicely done. Let's go look at the example right underneath this. It's another one dealing with perpendicular lines. We want to find the value of x and y so that these two lines are perpendicular. We have line PR. Here's PR. And we have line QS. Here's line QS. So because they are perpendicular, they are forming right angles. Over here where x is, because I have x as part of this angle and as part of this angle, I notice that they are adjacent angles. They share this side. So angle SQT together with angle RQT equals 90 degrees. SQT is 5x plus 6. And RQT is just 2x. And when I combine those, I get 90. We're going to combine our like terms together. 5x and 2x would give me what? 7x. So 7x plus 6 equals 90. We minus 6 from both sides. What's 90 minus 6? 84. And then we divide both sides by 7. What is 84 divided by 7? 12. X is 12. And then on the other side, angle PQS, that's where y is, and there's only the one angle there. Angle PQS is 90 degrees. And angle PQS is 4y minus 2. So 4y minus 2 equals 90. I add 2 to both sides. I get 4y equals 92. We divide both sides by 4. What is 92 divided by 4? 23. Y is 23. On the first one? So this angle right here is the right angle. SQT is just this angle. RQT is this angle. And I have to put that angle together with this one to get the right angle. On the other side, it's just this.
So that's how we find 90 degrees in most circumstances.
I mean, you have to look at the figure.
I mean that's similar.
You have to look at the figure. It's all based on what's shown in the figure.
Right.
It's all based on what's shown in the figure. Right. I want to recap what we've talked about with our special angle relationships now, and then I've got just a couple more problems for us to go through and solve. Complementary angles. These are two angles that add to 90 degrees. Two angles that add to 90 degrees. Complementary angles does not mean 90. Complementary angles means two angles that plus to 90. Supplementary angles are two angles that add to 180 degrees. Again, supplementary does not mean 180. Supplementary angles means they add to 180. Vertical angles will always be congruent. These are opposite angles. When two lines cross.
What do you mean by opposite? Like they go in the opposite direction?
Opposite sides. So like here and here. One's on top, the other's on bottom. Or here and here. One's on the left, the other's on the right. They're on opposite sides of the X. We did a pretty good job on the skills check identifying vertical angles. I was very impressed. We seemed to struggle with linear pair. Linear pair are two angles. I had a lot of people giving me lines and rays. Linear pair are two angles. These are adjacent and supplementary. What does supplementary mean again? Adds to 180. Together they make a line. And then last but not least, we have this new relationship that we just talked about, perpendicular. This is where two lines, or they can be segments, or they can be rays, intersect at a right angle. So 90 degrees. Yes, ma'am. All right. There are 4 problems that I would like to go over with you guys. Starting with the one at the very bottom of the page here. It tells me the measure of angle A is 2x plus 33. And the measure of angle B is 3x plus 15. Then it says angle A and angle B are complementary. What does complementary mean again? Adds to 90. When I see that things are complementary, I know that something plus something else equals 90 degrees. In this case, they told me that angle A plus angle B add up to 90 degrees. And then we were told right here that angle A is 2x plus 33. And that angle B is 3x plus 15. And those add up to 90. So now to solve this, we need to combine our like terms. Our x's, 2x and 3x, would combine to give me what? 5x. And then we combine our constants, our numbers with no variables. I have 33 and 15 combined to give me 48. So 5x plus 48 equals 90. Then we minus 48 from both sides. I get 5x equals what? 42. And then we divide both sides by 5. Do I get a whole number when I do that? No. X is going to be a decimal. Decimals don't mean you did it wrong. What is this one? 8.4. We are supposed to find the measures of both angles. So I need the measure of angle A. That was 2x plus 33. And we just figured out that x is 8.4. So 2 times 8.4 plus 33. What do I get from doing 2 times 8.4 plus 33? 49.8. And then we also need the measure of angle B. Measure of angle B is 3x plus 15. And so we're going to sub in 8.4 in the place of x. 3 times 8.4 plus 15 gives us what? 40.2. And they said at the beginning that these two angles were what kind of angles? Complementary. So I know that my answers should do what? Yeah, these should add to 90 degrees. Let's check that real quick. 49.8 plus 40.2. Well, 8 plus 2 is 10. Bring down my decimal place. 9, 1, and 0, that's another 10. 8 and 9, I got 90. So we are correct. Let's flip over to 11 and try another one that is very similar to this. Only this time, instead of complementary angles, what kind of angles are we looking at? Supplementary angles. What's the difference between complementary and supplementary? Yes, supplementary adds to 180 degrees. So when I see supplementary angles, I know I'm going to have something plus something else equals 180. Let's look at what those somethings are. It says the measure of the larger angle, so larger angle equals 6 less. When you see less, Does that mean plus, minus, times, or divide? Minus. So 6 less would mean minus 6. Then triple. What operation does triple mean? Multiplication. Specifically, we're going to multiply by how much? Multiply by 3. Triple the measure of the smaller angle. Do we know how big the smaller angle is? So what should we call it? X. All right, so my smaller angle is X. The larger angle is 6 less than triple that. Okay, hold on. I got to think about how to write this down now. So I have to think about order of operations, PEMDAS. Which thing comes first in PEMDAS? Minusing or timesing? Multiplication comes first. So we do 3x, and then after the 3x, we do the minus 6, because I can do any adding or subtracting after I do that multiplication. We're at the top of the next page, dear. So these are the two things that are going to go on those lines that add to 180. 3x minus 6 and x. And then we combine our like terms, 3x and x together, and I get 4x minus 6 equals 180. We add 6 to both sides. So 4x is 186. And then we divide both sides by 4, and we get that x is what? 46.5. What did we just find? The smaller angle. So my smaller angle is 46.5, and we put the units of degrees on the end because it's an answer for an angle. So here's my smaller angle. We still need the larger angle. The larger angle is 3x minus 6, and we just figured out that x is 46.5. So 3 times 46.5 minus 6. That comes out to be what? 133.5. Pop those units of degrees on there. And what should be true about my answers? Yes. Should add up to 180 degrees. So let's check that. 46.5 plus 133.5. 0.5 and 0.5. Well, 5 and 5 makes 10, so carry the 1, bring down the 0, bring down my decimal point. 6 and 1 is 7, plus 3 more, that's another 10. 4, 5, 5 and 3 is 8. We get 180. Very nicely done. All right. Let's go look at number 8. Yes, sir. Yes. I notice on number 8 they want me to draw a picture. It says that ray RS and RT are perpendicular. So I need a ray. I'm going to put points R and S on this ray. And then I need a ray RT that is perpendicular to it. How should I show that they're perpendicular on the picture? Little square, little box in the corner showing me that it's 90 degrees. Point V lies in the interior of angle SRT. Well, here's angle SRT. Is the interior this? Is it this?
Yes.
So somewhere in there, wherever I want, there is a point V. Says that the measure of angle SRV, well, I don't see an angle SRV. I need to draw in this ray so that now I have angle SRV right here. The measure of angle SRV is 9J minus 44 degrees. And the measure of angle VRT is 6J plus 14 degrees. Those two angles are side by side. They share this side right here, so they are adjacent. And when you put them together, they make what kind of an angle? 90-degree angle. What do we call two angles that add to 90 degrees? Complementary. So complementary angles means something plus something else equals 90. So 9J minus 44 plus 6J plus 14 equals 90. We're going to put our J's together. What is 9J plus 6J? 15J. And then combine my two other like terms. I have a negative 44 and a positive 14. Negative 30, so minus 30 equals 90. We're going to plus 30 to both sides. I get 15J equals 120. And then we divide both sides by 15. J is 8, yes. So with that in mind, what do I need to do with that answer now? Plug it in. The measure of angle SRV is 9J minus 44. So we're going to do 9 times 8 minus 44. What is 9 times 8? 72. And 72 minus 44, 28. So SRV is 28 degrees. And then angle VRT, that was 6J plus 14. And again, we figured out that J is 8, so 6 times 8 plus 14. What's 6 times 8? 48. And what's 48 plus 14? 62. What should be true about those two angles? Should add to 90. So let's check that. 28 degrees plus 62 degrees. 8 and 2 makes 10, so carry the 1, bring down my 0. 2, 3, yep, I get 90. So we are good. Let's do the problem down at the bottom of the page. And I will warn you, I found a typo in this problem. It's the very, very last piece. So I'll tell you what that correction is when we get down there. I want to identify what special angle pairs we're looking at. So we have angle CEF, this angle right here, and angle BEH, this angle right here. What do we call that special angle pair? They're opposite. What do we call opposite angles? Vertical angles. Opposite angles are vertical angles.
How do you know they're vertical angles?
Because it makes an X. See that X right there? Yes. Yep. When you see that X and they only touch right in the center of the X. All right, then we have angle CEB, this angle here, and angle CEF, this angle right here. What do we call that special angle pair? They're not perpendicular. Linear. These are linear pair angles. See, they share this side right here, and the sides that they don't share, this one and this one, make a straight line together. That makes them linear pair angles. All right, next, CBE, this right here, and angle GBE right here. What do we call that special angle pair?
Adjacent.
They are adjacent. There's something else I notice about them too, but let's write down adjacent first. So I noticed something just on the other side of those two angles. There's this little box in the corner here. And that box is being formed by these two lines right here and here. This and this. So what would be true about these two angles put together? They would also make a right angle. What do we call two angles that make a right angle together? Complementary. So these are also complementary. Adjacent angles aren't always complementary, but this pair is. Yes, sir.
Is number B, can that be supplementary?
They are also supplementary, yes. Nice call. All right. If the measure of angle ABD, let me go find ABD on here. ABD, this angle right here. If that is 52 degrees, how big is angle ABC? How can I figure that out? Yep. What do we call this angle pair, ABD and ABC?
I know they make a straight line, so
They make a straight line. So they're a linear pair, yes. Yes, we're going to minus 52 from 180. You're absolutely right. All right, so I do 180 minus 52. What do we get? 128 degrees.
So are all linear pairs supplementary?
Yes, all linear pairs are supplementary. What about angle ABD, and angle CBE, this one here. So don't pay attention to the orange one, just the blue and the pink. It's 52. Tell me why. Yep, it's an opposite angle. It's a vertical angle with this first one. So that is 52 degrees. Because these two angles are vertical angles. All right. Here's where my typo is, right here. The B and the G should be flipped around. It should be CBG. Measure of angle CBG. Well, here's C. Here's B. Here's G. How big is that angle? 90 degrees. Because ray BH, this ray right here, is, and then they have this weird symbol right here. This symbol right here means perpendicular. Ray BH is perpendicular to line BC or line DC. I can call it DC or BC.
So when it means that line BH is perpendicular to DC, it means that they both make a 90-degree angle.
Means that they make 90-degree angles, yes.
Okay.
All right. With our last couple minutes, we're going to turn to page 12, and then we'll go to page 13 also. Page 12, we're going to talk about the things that we are and are not allowed to assume from figures. This is a really important conversation that we've been needing to have for a while, but we had to get used to looking at our figures first. All right. Certain relationships can be assumed, but most cannot. All right. So the list of things that I'm allowed to assume is very short. I am allowed to assume, they make it look longer, I'm allowed to assume that things that look coplanar are coplanar, that things that look collinear are collinear. I'm allowed to assume that things that look like they intersect really do. I am allowed to assume that point H right here in the picture is between points G and J. So if it looks like it's between it in the picture, I can assume that. I can assume that a point is on the interior of an angle. I can assume angles that are touching or adjacent angles. I can assume linear pair angles. And if I have linear pair angles, I am allowed to assume that that linear pair is supplementary. Things that I cannot assume. If they look perpendicular, I cannot make that assumption. If angles look congruent, or if segments look congruent, I am not allowed to assume that. I am allowed to assume that things that look like vertical angles really are. And I am allowed to assume linear pairs, which I already mentioned. So now I want to look at the next page. We're going to run through just a couple quick examples. You're just going to tell me yes or no. Can we assume this is true from the figure or no? Ray CE, this ray right here, and ray CF are opposite rays. They make a line. Yes. I'm allowed to assume that. Angle BGC and angle KGC are a linear pair. Can I assume that? Yes. Yep. They share a side. Their non-shared sides make a straight line. Angle ABJ, this angle right here, and angle CBG, this angle right here. Can I assume that those are vertical angles? Yes. Are there any angles on the picture that are being marked as congruent? No. Then can I assume things are congruent? No. Are there any right angle markings in the picture? No. So can I assume things are perpendicular? No. Doesn't matter where they are. What does complementary mean? Adds up to 90. Do you guys see any right angle marks anywhere here? Can I assume this? No. Angle ICH, this angle here, and angle HCD, this angle right here. Can I assume that those are adjacent? Yes, they share a side. What do bisectors do? They split things in half. They make two congruent angles, two same size angles. Are any of the angles up here marked as being the same size? Can I assume that there's an angle bisector then? No. All right, very last thing. I want the things that I cannot assume from the picture. Can we assume that there are complementary angles here, angles that add up to 90? I see a 90-degree angle here, but are there two angles together that make that 90? No, then I cannot assume that. Can I assume that things are linear pairs? Yes. Can I assume that ray HL right here is perpendicular to HJ right here? This I could assume is perpendicular, but not this. Can I assume that things are adjacent angles? Yes. Can I assume that HL and HM are perpendicular? Yes, because they have that right angle marking there. Very nicely done today, guys. Homework is due on Monday. And just to give you a little heads up about next week, we have exactly one more lesson until we are done with this module. It is very short. On Monday, we will finish the whole thing. So we'll grade homework on Monday. We'll do your last lesson. You'll get your last homework. Since the lesson is very short, it's only one day. You have a homework that's going to be due the next day. It's very short. Very short homework assignment due the next day. Your second skills check of the module will be on Tuesday. Test is on Thursday. Have a great weekend, everybody. I'll see you on Monday. Thank you.